Okay, grade 8. So this is lesson 5 in chapter 1. Okay. It says negative exponents, lesson 5. It's on page 43. Okay. That's where it starts. Okay. So, chapter 1, lesson 5, negative exponents. Today's date, September 16, 2020. Okay. Now, what do we mean by negative exponents? It doesn't matter whether your base is negative or positive, as long as your exponent is negative. So then we will say your power has a negative exponent. Okay. So what is important is the exponent. So before we start with the negative exponents, we have to look at the zero exponents, just as the book explains. The book states we need to discuss what is a zero, but what happens when the exponent is zero. We've seen previous examples as we were coming along before we got to this lesson. So let us just remind ourselves. So any non-zero number to the zero power, the answer is 1. So if my base is raised to the zero power and it is positive, my answer will always be 1. And that's what I've written here in words. As long as x is not 0 and as long as x is positive. This rule can only work if x is not 0 or if your base is not 0. And that's why I said 0 to the power of 0 is not equal to 1. Check that with your calculator. Okay? Now, if your base is a negative and there is no bracket, then you raise it to the 0 power, your answer will always be negative 1. Okay? As long as the base is not in a bracket. That is what I said. So, and I also wrote here in words, this rule cannot work if the base is 0. Okay? So this rule doesn't work if the base is 0. So let's see a couple of examples. I have a variable as a base and it is positive. So a to the 0 power is positive 1. I have a fraction as a base and it is positive because there's no negative sign out here. So positive 1/2 raised to the 0 power is 1. I have a base that is positive because there's no negative sign in front of 13. And I am raising to the 0 power. My answer is positive 1. I have a base, but it is negative because there's a negative outside here. But I'm raising it to the 0th power, so my answer will be negative 1. I have a base that is a decimal. This is 6/10. It is positive because there's no sign outside my bracket. Therefore, my answer is 1. I have a base that is negative, and I'm raising it to the 0 power. My answer is negative 1. I have a base that is positive, even though inside is negative, but the whole base is positive because outside here there is no negative sign. Therefore, this is equal to 1. So we did the same. So here is a variable, and this is just a value. So this is a variable, and this is a number. So there's no difference. The answer is that. And then you have 10,000 raised to the 0th power. The answer is 1. Okay? So now let us look when your exponent is a negative. So this is the second part of our lesson, negative exponent. So what does that mean? When your exponent is a negative, it means the power is a fraction with 1 in the numerator. Always. When you have a negative exponent, you can write it as a fraction with 1 in the numerator. No other number can go in the numerator but 1. Okay? Then the power is representing a very small value. Remember, a fraction whose denominator is 1, whose numerator is 1, is a proper fraction because the denominator is going to be bigger than the numerator. Okay? So, Proper fractions are between 0 and 1. So any number between 0 and 1 represents a very small value because it is not yet 1. It is before 1. Okay? On the number line. When I'm drawing my number line and I'm thinking about proper fractions, so this is 0, this is -1, and this is 1 on my number line. Here I will have proper fractions that are positive because they are on the right of 0. So this side will be positive proper fractions. And on this side, there will be negative proper fractions. So in between 0 and 1, the numbers that appear there are called proper fractions, okay? That's what I needed to explain to you. And if you have a proper fraction, this represents a very small number, a very small value, okay? Negative powers are a result of repeated division. That's what they represent. That means you're continuously dividing, okay? All right. Now, this one says write each expression using a positive exponent. That means they will give you a negative exponent, and now you need to write it as a power with a positive exponent. Okay? Or it means your answer should not have a negative exponent. That is better. Your answer should not have a negative exponent. All right. So 8 raised to the negative second power. You just write 1 in your numerator and you write 8 out of 2 without the negative sign. And you box it. And then you can simplify further. 1 out of 8 to the second power means 1 out of 8 times 8, which means 1 out of 64. And you box your answer. Okay? Now here you have a negative base. If you have a negative base, just write it in the numerator, negative. And then you write 1. And then you take your power and you put it at the bottom and you remove the negative sign. So that means it's -1 out of 7 to the 4th power. What does that mean? I'm going to repeat 7 in the denominator 4 times. And when I do that, I will get -1 out of 2,401. Okay? You can, it's best practice, you just put the negative on the numerator. But it doesn't matter. You can put it in the numerator, in the denominator, in the middle. Okay? As long as your answer is still a negative. If the question is a negative, your answer should still be a negative. Okay? All right. So c to the -6th power becomes just 1 out of c to the 6th power. Negative d to the -3rd power becomes -1 out of d to the 3rd power, and you box your answer. Okay? Now let's go to the third part of our lesson. The other part is you'll be given a fraction, right? Each fraction has an expression using a negative exponent other than -1. That means do not use -1 as the exponent. It has to be either -2, -3, like that, okay? So let us look at this one. We have 1 out of 3 to the 2nd power. This is easy. It's already in exponent form, you see? So they've already done it for you as a power. There's an exponent already in the denominator. And we said if you see 1 on top, it means you can write it as a power with a negative exponent. Just like that, okay? The 1 disappears and it stops being a fraction in terms of when you're writing it as with a negative exponent. Okay, now you have this fraction, 1 out of 125. When you have your denominator, try and see which numbers can you multiply the same will give you the denominator. Okay? So if it ends with 5, try with 5s. Like do 25 times 25, or 5 times 5, or 15 times 15, like that. So you work smart. If a number ends with 5, you try 5s, you try 15s, you try 25s, 35s, like that to check. Okay? So I know that 125 is 5 times 5 times 5, which means it's 5 to the third power. And then how can I write it? 5 to the negative third power. Okay? There. Let's do 1 out of 100. 1 out of 100, I know that 100 is 10 times 10. Okay? And that means 10 squared. So this is 1 out of 10 squared. And then I just write it 10 to the negative second power. Okay? And I box my answer. Okay? And you cannot have two bases. You have to only have one base. So here you cannot write 5 times 25. No, that will not be correct. You just have to make it one base. Okay? All right, let's continue. So what did I write? If your denominator is not a power, then you must find what same number can you multiply repeatedly so you can write it as a power. Okay? That is what I mean. So you must know your times table. And you check with 2 times 2 times 2, 2 times 2, like that. Or you do 3 times 8 times 3, seeing which number will give you your denominator. Okay? Alright, so this is part 4 of the lesson. Now you have decimals to powers of 10. You will be given a decimal that has zeros and 1. Okay? The decimal starts with 0. If the decimal starts with 0, it means it's between 0 and 1 on the number line. So we are looking at all decimals that start with 0 between 0 and 1, but they have 1, or they have a unit, 1, in the decimal, okay? So when I have this decimal, I am going to write it as a fraction. I need to know how to read correctly. So this becomes 1. This is 1,000th, because 1 is at the thousandth place. So I'm going to write 1 out of 1,000. And how do I write 1,000? 1,000 changes to become 10 to the third power. How do I know? Because 10 times 10 times 10 is 10 to the third power. Okay? And 10 times 10 times 10 is 1,000. Okay. So now, since it is 1 out of 10 to the third power, I can write it with a negative exponent, which is just 10 to the negative third power. The same, I follow the rule. 1 out of 100, which because it is 100th, and then 100 is 10 to the second power, and then that becomes 10 to the negative second power, and that is my answer. Okay? And this one is 1/10, so 10 means 10 to the first power, and because this is a fraction, I just write 10 to the negative first power. Okay? All right, so now let us do this part where we are simplifying. So you have to remember things we learned in lesson 3 and 4 to apply over here. 4 to the 9th power multiply 4 to the negative first power. My bases are the same. If my bases are the same, I am multiplying my powers, so I will add the exponents. Okay? I have checked. My bases are the same. What am I doing with my powers? I am multiplying them. If I am multiplying them, then I will add 9 to negative 11. So that's what I wrote here. 9 plus negative 11. I circle the positive and the negative. When my signs are different, they become negative. We learned this in grade 7. Okay? So this now becomes 4. 9 subtract 11. 9 subtract 11 is negative 2. How do I know? Where's my pencil? Okay, let me just use my pen. Okay, how do I know? So How do I know 9 minus 11 is going to give me negative 2? 9 is positive. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I have negative 11. So then I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then make my zero pair. So all these are zeros, which means I don't need them. And what am I left with? 2 negatives. So that's how I know 4 raised to negative 2, because 9 minus 11 is negative 2. Okay? Also, I know that I cannot remove 11 from 9 because 11 is bigger than 9. So since 11 is bigger than 9, my answer will definitely be negative. Then I ask myself, how many spaces from 9 to 11? 2. So there is so many strategies you can apply. You can either draw, you can ask yourself the questions just like I asked. Okay? All right. So since this, I can leave my answer with a negative exponent. I can write it as a fraction. I can continue and simplify it. So 4 to the negative second power becomes 1 out of 4 squared. And then 1 out of 4 squared becomes 1 out of 16 because 4 times 4 is 16. Make sure you don't say 4 times 2. This is 4 times 4. Okay? 4 times 4. That's why it gave us 16. All right. Let's try this one. So we have 3 to the negative 5th power. Multiply 3 to the negative 13th power. My bases are the same. I will add my exponents. Okay? So now I have a negative plus a negative. When I put my signs together, they become a negative. So negative 5 minus 13 becomes negative 18. Okay? So how do I know? Negative 5 and negative 13. 1, 2, 3, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. I cannot make a zero power, so I count them all together. So this is 13, 14, 15, 16, 17, 18. And they are all negatives, so there is my answer. 3 to the negative 18th power. Or how else can I say this? I have negative 5 and I'm increasing it by negative 13, meaning I'm going to have more negatives. So negative 5 being increased by negative 13 means I'm going to have now negative 18. Okay? So since my exponent is a negative, I can leave it like that. I can change it to where my exponent is no longer a negative, meaning I will write it as a fraction, and then I can continue simplifying. Okay? All right, so now let's look at this one. So this is, my bases are the same, and I am multiplying, so I should add my exponents. Negative 3 plus 4 is just 1. So 7 to the first power, which is just 7. So you have to remember your rules for integers. Adding and subtracting integers, the way we learned when we were in grade 7. All right. So here, as you remember in lesson 3, when I am dividing powers with the same base, I subtract the exponents. So W is raised to the negative third power. And I always start with the exponent that is in the numerator. So negative 3 minus negative 7. Minus because you're dividing, because of this line. So I'm subtracting these 2. So a negative and a negative together becomes a positive. Okay, like that. When I have two negative signs together next to each other, they become a positive. So now my new step is negative 3 plus 7, and negative 3 plus 7 is just positive 4. Okay, so this is w to the 4th power, and I box my answer. So you have to ask yourself, are my bases the same? Am I multiplying or am I dividing? If I am multiplying, then I add my exponents. If I am dividing, then I subtract my exponents. Okay? All right. Let us look at this one. We have 5 to the 3rd power divide by 5 to the 8th power. My bases are the same. I will subtract my exponents. 5 to the 3rd power minus 8 becomes 5 to the negative 5th power. How do I know? Positive 3, negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I make my 0 pair. I don't need this. So 1, 2, 3, 4, 5. So I have 5 negatives. And because my exponent is a negative, I can write it as a fraction. 1 out of 5 to the 5th power. I can expand this and it becomes 1, or I can evaluate this, or I can simplify this, and it becomes 1 out of 3,125. And then I box. We don't use commas in the denominator. Okay? Don't use commas in the denominator. Or you can. Yeah, you can. Why not? Put comma there. Yes. It is in the thousands. Read the decimal. Read your numbers correctly. So 1, 2, 3, comma. 1, 2, 3, comma. Okay? Like that. I don't think there's another one. We need to put a comma. Or here. For the 1,000. Put a comma. Okay? Alright. And that's it. So now please do your examples on page 44, A to H, and J to M on page 45. And then we'll talk tomorrow, okay? And complete your Aleph lessons. Bye.